This example illustrates how you can measure the mass of other things in the solar system and in fact other things in the universe. We start with things that can be observed. For example, how long it takes the Earth to rotate around the Sun, 3.2 times 10 to the 7 seconds. That's a year. The radius of the Earth's orbit, 1.51 times 10 to the 11 meters. And the gravitational constant, 6.67 times 10 to the minus 11 Newton meters squared per kilogram squared. Using that information, we can determine the mass of the thing that the Earth is orbiting, the Sun. How do we do that? Well, we start by realizing that the reason the Earth is traveling in a circle is because it is experiencing a centripetal force, and that centripetal force is supplied by gravity. So the gravitational force equals the centripetal force. Then we take the equations we have for gravitational and centripetal force. Gravitational force is the gravitational constant times the mass of one object, the Earth, times the mass of the other object, the Sun, divided by the distance between them squared. And the centripetal force is the mass of the object that's moving, the Earth, times the speed squared divided by the radius of the circle. The mass of the Earth cancels, and we find that the gravitational force times the mass of the Sun over the distance equals the speed squared. Now look what we have. We have an equation that has a gravitational constant, that's something we know. The radius of Earth's orbit, that's something we know. The mass of the Sun, that's what we're trying to figure out, and the speed squared. If I could just determine the speed, I could determine the mass of the Sun. Well, we've been given enough information to determine the speed because we've been given the period of Earth's orbit as well as the radius of its orbit. That's enough to determine speed. Remember, the circumference of a circle is 2 pi r. So the circumference of Earth's orbit is 2 times pi times the radius of Earth's orbit, 1.51 times 10 to the 11 meters. That works out to 9.5 times 10 to the 11 meters. Well, that's the distance that the Earth travels in one orbit. So I can determine the speed of the Earth by taking the distance it travels in one orbit, 9.5 times 10 to the 11 meters, and dividing by the time it takes to make one orbit, 3.2 times 10 to the 7 seconds. When we work that out, we find that the speed of the Earth in its orbit is 3.0 times 10 to the 4th meters per second. Okay, that's an important number, so we're going to save it. Now let's go back to our equation we had. Remember, we already determined the equation, capital G times m Sun over r equals v squared. Now we have everything except the mass of the Sun. So we put in everything we know. Gravitational constant is 6.67 times 10 to the minus 11 Newton meters squared per kilogram squared. The mass of the Sun we don't know. The radius of the orbit is 1.51 times 10 to the 11 meters. And the speed we just determined to be 3.0 times 10 to the 4th meters per second. When we solve for the mass of the Sun, we get 2.0 times 10 to the 30th kilograms. So without ever going to the Sun, without ever touching the Sun, we can determine the Sun's mass by simply determining how quickly the planets orbit the Sun. If an astronomer looks out in space and sees one thing orbiting another thing, then it's possible to measure the mass of the thing that's being orbited using these equations.